Yes. So I will be starting, and Thomas will be following me. And the theme, as mentioned, a bit of challenges with microservices and the data area. First of all, I'm Markus Backman. I work at Swedbank as a technology enterprise domain architect. My background is I'm a software engineer. I like to code still, even if I'm apparently nowadays more using PowerPoint as most architects do, apparently. I also like IoT, we'll come back to that as well. But my day job is basically all the architecture decisions for the bank when it comes to data center, cloud, application development platforms, how applications integrate with each other, workplace, and a lot of other areas. So that's kind of my day job. But to make this a bit more interesting, we will actually start off with a bit of a movie instead. I know it's after lunch, everybody is tired, so movie time is kind of the perfect way to get started. So, here it is.
Ladies and gentlemen of Vilnius and planet Earth, we confronted a towering legacy. We once inhabited a monolithic world, bound by limitations, confined by the familiar. A code base of 16 million lines, born in the year 1999, carrying with it 204 releases of the past. The monolith was ingrained in our culture, and our efforts to modernize it fell short. We recall the moment when we envisioned the Andromeda platform, born of the microservices philosophy. The platform should define our ideals of collaboration and decentralization, and each team would get a solar system of their own. Technology was easy, to change the culture would be the great challenge. The year 2019 marked our first steps toward Andromeda when we launched the first rocket that enabled teams to bend space-time. In this new galaxy, we are now 77 teams strong, collectively running 258 applications. We have seen a steady uptake from teams using the managed services provided. The teams are themselves responsible to ensure the survival of their own solar system. The space-time services was the fertile ground to enable teams to safely explore on their own. With an exponential increase of teams that journeyed from the monolith to Andromeda, we have witnessed 6,071 deployments in this year alone. Even with this exponential increase of introduced changes, we are yet to see any instabilities in the galaxy. This, my friends, is our legacy, a journey from monolith to Andromeda, a journey that transforms the cosmos and ourselves.
Yes, and as seen, it's basically me as an architect has no skills, and our chief product owner of the microservice platform has created this with the use of machine learning and all the nice, fine stuff that has happened, like ChatGPT to create the transcript and so on, which is really, really fun to play around with. But we actually rendered this movie long ahead before this conference. Actual number of deployments was listed 6,071. I checked this morning, 8,900. So currently we are churning around 1,200 deployments per month, and it's still around 77 teams, but I think it's 270 applications. So it's still going up. But when it comes to large enterprise with a lot of teams, so like how do you actually scale this? How do you ensure that teams uses the good practices that you kind of want to push forward? And for us, directly when we said we actually need to do something, we need to create something new, we're going to offer it to all our internal development teams. Well, we said we will actually establish a platform team. So a platform team that actually treat this platform as a product that is being used by developers. And developers should actually like to use the platform, not being forced to use it, because I don't really think of that type of governance. But that basically means that that platform team is responsible of ensuring self-service capability and minimize connective load for all the developers. So they should concentrate on the business logic more than actually understanding all the underpinnings. But as mentioned, they are still the one that will be the one that operating and owning the application. So it's full on DevOps, which means like you still need to be able to do and understand most things. So our approach, well, it's called Andromeda. And why did we use a space theme? I'm a space geek. For one, the other is kind of space is more fun to talk than banking, so why not? But this is a one-liner, a developer-friendly application development platform based on microservice architecture with managed services for develop, deploying, and operating cloud-native applications. So, of course, it's built on Kubernetes technology, but Kubernetes is just a platform for build other platforms on, as we know. So this is our platform on top of that platform. It's always platform all the way down. Before we actually said anything, we said, what do we actually want to accomplish? And these are the 5 principles that we set initially before we started, and this was back in 2019. And we didn't have anything written, no code, nothing, no decision, nothing. But we said, developer experience, developers should be happy, they want to use the platform, they should not be forced to use it. We wanted to foster a culture where every team do daily deployments. And with a bank with change control and processes, it's a bit of a challenge. We come into that. But also, we wanted to be compliant by design. So that means that the teams themselves shouldn't understand all the underpinnings of our change process, how to actually get things into production and what's needed. The platform team should make it that simple. And we wanted to scale the full enterprise. We hadn't really had any developer platforms that actually scaled all our 4 home markets, but we wanted to be pushing to that. And of course, microservices, team independency, Conf law. Don't try to fight against Conf law, you will lose, always. But definitely some challenges on the ordinary people technology processes. So we talk about culture. We'll show how we actually approaching that, because that's an important part. The technology part is usually what I say, this is easy. We as technologists, we can solve technology, we can bend technology in the direction we actually would like to. Processes, as a large financial institution, well, we kind of have a lot of compliance, which means that we're having a lot of internal processes that needs to be followed. So changing those is definitely also a bit of an interesting part. The platform, as I said, technology is easy, and I will not go into much of the technology today, but as I said, it's Kubernetes in the bottom. But all of this layering that is that we have a clear purpose of all this. So we have developer tooling. So there we have everything from a command line to generate your application and interact with the basic services. We will come into another service soon. A lot of documentation, the pipelines, CI, CD, and all that. Then we have libraries. So easy consumable libraries you can include into your application. As Andromeda and the space-time theme is Java and Spring Boot, but have people using Kotlin as well. You can still leverage these libraries. Then a lot of other platform services that are services running as something you can interact with your application. And then it comes to you're building your own application, owning and operating them. But one example, developing tooling. So for instance, we actually have a small little bot called Renovate. This is an open source project. If you haven't used it, please start thinking about it. But let's maybe
Hello, I'm Renovate, your friendly automated dependency manager. My mission is to keep your software project up to date and secure by automatically handling your dependencies. I'll open pull requests, run tests, and make sure your code stays fresh and reliable.
So basically a bot looking at all your dependencies on your application that you're owning as a team. When a new open source library comes with a new patch or version, It basically open a pull request, do the dependency change, run the pipeline for you. You come in, you have a green tick bar. Do you accept? Yes. So this is actually accomplished, and today it takes an average for all Andromeda teams, all the 77, for any dependency update happening out there in the world or within platforms library features, it takes 6.5 days before it's out in production. For critical vulnerabilities, it's hours. Which for me means like, this is just a tool to help people actually do the boring part. Of course, it needs to be ensured that you have tests, otherwise you will not trust it, and we force people to actually have tests before they go to production. And we have changed the culture of doing deployments. So that's why why we see these numbers. But coming back to culture. So this is actually the start page of the platform documentation site. And one thing that is very open with is that all the data and metrics that we are having is open available for everyone to read. And we also put on the start page the actual team that is doing most deployments. Because we kind of want to push that if you are a team that are pushing the boundaries, you will actually be noted. Another thing that we are pushing, and this is of course just for fun, but gamification. So all teams get achievements depending on what you're doing on the platform. So everything from actually shipping Jira tickets to production, which we know is that the business outcome? I don't know. At least it's a metric, but it's just fun parts. Like if you have 10 deployments successful in a row, you actually get an achievement. But you also get an achievement if you have 10 failures as well. Because failure is okay, but that just means that we have an automatic rollback in the pipeline, which actually didn't impact any of our users or customers. So we have the safeguards. And this is like saying, we know it's okay to fail. Everybody does it. And actually, there are quite a lot coming up. Is of course Black Friday, and during Black Friday we have quite a lot of extra traffic. So deploying on a Black Friday, and when a Black Friday actually coincides when most people get their salary, that's even more nice of a risk. But you actually get an achievement if you deploy on Black Friday, because that is kind of the culture we want. It should be boring, should be repetitive. It should take more conscious things for you to stop doing deployments and actually just doing them. We also communicate success. We don't communicate failure. We says we want to learn from things. So every team actually get their own metrics, an email stating where they are, and they can see in relationship with all the other team where they are, like position 71 of 127 here. So you're kind of in the middle of the bunch. But then also, like, we are pushing the same message up the management chain, but then we start aggregating. So if you're a higher up manager, you might have 20 teams running things on Andromeda, 70 applications, whatever. But then we aggregate the statistics, how that trend is going, and we also communicate the team of the months. So basically get upper management to say to the team that actually have seen the good progress you're doing. Another thing that also culture-wise is that we want to, of course, encourage people to continuously updating and maintaining their application. So every Monday morning, every developer gets an email like this. So these are your 3 applications you are having in production. You can see very easily with green and yellow, is there stuff I should care about? If there's a red, you should definitely care about it. But in this case, it's just yellow. So for instance, here we can see the first service is running an old minor Java version. Now this is unfortunately before Java 21. Now most people have upgraded to Java 21, so we're actually not supporting Java 20. And of course, you can see that you have pending updates. So down there, you can see that they have approved one pull request coming from Renovate, so a dependency update, but they have 7 open pull requests that not yet has been approved by any of the team. So just waiting there. And having approved a pull request, well, it doesn't do anything before it's in production. So that's why we're kind of pushing this message, trying to get more people to do the job. When you do a deployment, you can accidentally get one of those emails. And here comes compliance by design. We actually have a full change process. And in there, it says that each service owner owning one of these microservice applications need to see what is the risk of doing this, what could be the potential impact. And if it's deemed major and critical, well, in that sense, you actually need to go to a change advisory board, meet other people saying, why are they so high risk? Are we sure? Can you really do a deployment? And no one wants to go to a meeting. Everybody wants to basically own their own decision. So today they get this email. Here we say, okay, you deployed a major risk. You then get, this is what your team are doing good, but also what you can improve. Very clear statement. And this is together with our process office is looking into like what are the culture and what are the risk-averse things we want to push that teams know how to use. Feature flag. Have they tried rollbacking the applications in production? If not, they should have done that because if there is an incident, they should know how to do that. This is now today after the fact, after deployment. It will be a forcing and the calculation will be 4 before you press the button in the future. So just by sending out this email, we've actually seen that the whole developer community has reduced the risk of major critical changes by 45% over a couple of months. Then, as I said, IoT, I like to play around and I also like to have fun at work. So the story is that I was on a vacation, I visited a Lego store, I saw the Saturn V rocket, space geek. Well, I need to buy that to build it, of course, I need a Saturn V rocket. The next is like, okay, but if I have some LED strip underneath, I could actually make it fire. That could be a nice little small project. Okay, let's build that. When should I fire it? Well, we have an automated pipeline and we have 75 teams doing basically between 40 to 80 deployments per day. Why not connect them? So I did. So this is actually behind me when I'm sitting in meetings at home in my home office. So this actually fires up in the camera a lot. So red means that someone actually deployed an application on the platform. Blue is that someone changed a feature flag in production. So start rolling out a new feature to a subset of our customers. So it's just a fun way to see that and bridging the gap of what we can't see, what's happening in a computer in a data center somewhere in the world, to actually I can see it behind me in my room all the time. And now it's starting that when I actually leave the office, it continues, it fires all the time. So I don't know where people are working, but it's fun. But coming to the other side, is like, okay, now with all these microservices, all this team doing independently changes all the time, well, we of course need to understand how can team work, what type of changes, encapsulation, API, non-backward compatible changes are important, but also like how we deal with data at scale. If you take a very simple application, you have your domain model where your business part, but you have your internal data model. You have the parts that are your data store, your database, could be an in-memory database, it could be a NoSQL. doesn't really matter. But you have your internal data model. That you should always protect. It's yours. You should be able to change that without any other important changes. But you also have your data that is exposed to others, your APIs. And here you need to describe your data, your APIs, and it could be both synchronous, asynchronous, REST, gRPC, it could be Kafka, MQ, and so on. So a lot of different technology that you're sending your data to others. And that needs to be very well documented and described. But you will also end up consuming data from other teams. And this is now when this starts mixing, when things become a bit more complex. So for instance, we have, let's say, a mobile app doing a payment initiation. A customer wants to do a payment. So we have some app doing a call to a payment service. To be able to do a payment, it needs to check, does this customer actually have the agreement of doing payment and the product is paying for it? It needs to have basic information about the customer, of course. But during that payment initiation, it also needs to send events. This customer wants to do a payment initiation to this account. And then we have another team doing the anti-fraud part. They get events that's coming from payment, but most likely will contain a lot of data from both customer agreement. So how to actually scale that in practice and large enterprise. And I will actually leave it over for Thomas to continue on that topic.
Okay, you can hear me now. Thanks, Markus, for a really inspiring story. And as you can see, this approach produces a lot of teams which produce more and more data. And how it works? Okay, so this is my first slide. My name is Tomas Šalkauskas, and as you can see, I'm metadata architect. And I'm working in that field about 10 years already. And what is metadata? Short answer is this is data about data. And I will try to explain why it's important, how we're using, and most important is how we're managing metadata. But instead of talking about data, I will talk about wine. Let's imagine you have one or many bottles of wine with such empty labels. What you can decide having such wine? Is it good? Can I use it in some daily cooking, or I should use it only in special occasions? Or maybe it's expensive and I can sell it and earn money? You cannot decide anything. And if you try, then bottle is opened and it's too late. So this explains essence of metadata. If we have label on bottle, we can read it directly, we can search internet and find interesting things. For example, this bottle was sold in 2010 for $300,000. So yeah, you can decide, you can make decisions based on metadata. And metadata is wine label in this case. And now I will talk a little bit about principles, why we're doing metadata management and how. So our enterprise principles are that we want to scale data management capabilities, and our organization wants to be data-driven. That means they need people who are making decisions, they need to trust the data, what they have. And of course, flexibility and API, what Markus was talking, modularity and APIs, different modules communicate with each other via APIs. So those are high-level strategy of organization. And we also defined principles how we manage data or information. Actually, there is small difference between information and data. And definition of information is that it's data what was processed so that a human can read and understand data. So information management, we treat information as a shared asset. we should define who is owner of that information, who knows most details about data, what is produced. Information should have common definitions. We should know where is master system, where information is produced. Other systems are just consuming this information. Information quality is always very important. It explains how we can trust our data, what we have. And information, of course, should be protected and used responsibly. So those are information management principles, and I will try to explain what questions raises immediately if people will start using data in the organization. So at first, what data do we have at all? Where this data is stored? We have a lot of databases inside the organization, so how to find relevant data, what I need? Who owns data? What data means? That's usual question and sometimes very difficult to find answer. What is security level? What data comes from? Again, very often I hear this question. I see report, but where I get data for that report? Then data was created, how data is transformed, and why we store this data at all? What is the purpose of that data storage? So a lot of questions raises immediately when people start using data. And what is our approach? How we provide answers to those questions? So short answer is central data catalog. So we are maintaining central data catalog, and I will explain on very high level the structure of that catalog. You see three levels, and top level is called conceptual level. It contains high-level definitions of data in the organization. And those definitions are not technology-specific. Those are conceptual definitions. Bottom layer, it's called technical layer. This is our IT systems, databases, APIs, all technologies where things are implemented. And in the middle, we invented that we need one more layer in the middle, which we call application layer. This middle layer allows to connect technical stuff with conceptual stuff. And application level explains data in a particular application, in a particular context, and with meaning which is relevant for that particular area. So having those three layers, we are able to have two types of lineages, actually. You can see horizontal arrows. Horizontal arrows explains how we move data from sources to targets, how we transform data, from where data comes from and where it's used. Vertical arrow is called semantic lineage. It allows to understand how our technical assets, technical storages are related with descriptions in a particular context and how this is related to conceptual level. So we can drill different directions and get answers to those questions what I showed before. And what is approach currently? How we maintain this central metadata repository? And one more thing I should say that conceptual level and application level, this is metadata managed manually by experts, by different specialists, while technical layer, we are collecting metadata in automated way by automated metadata scanners. And right now our approach is that we have central metadata team, which is building scanners for different metadata sources and pulling this metadata into data catalog. And we are currently supporting most standard and widely known technologies like Oracle, Informatica, or Teradata, Azure Cloud, Oracle, etc. But we also have a lot of legacy technologies and custom technologies used what are transforming our data. So this is a journey, how to collect all this metadata in our central catalog. But you could ask why we need to collect this metadata into central catalog. What is the value of that? And I have several short answers about value of data in a central catalog. So having collected metadata in one place allows to answer some of those questions that I showed before. So what data do we have? We have everything in one place. Where it's stored, we can find storage in the same place independently of storage technology. Because usual situation is that every data storage has own metadata, but it's hard to get access to that specific technology, and you need to know details about that technology, how to find this metadata. But when we have metadata collected in a central repository, all this is in one place. And of course, the same metadata repository provides answers like what this data means, why we store this data, who is owner of data, who is the person who we can ask question about data meaning and usage. And last point, which you see, it's said most difficult questions. It's data lineage related questions. So where this data comes from and how data is transformed. Those questions are especially hard to find answers because data transformations, you as developers most probably know very well that when you are creating deliverables, software which deals with data, you're not thinking too often about metadata and how others will collect this information about transformations that you have created. So I will show how we are trying to approach those types of challenges. And what are those challenges? So first thing what we just discussed with Markus before meeting, naming conventions. Maybe you faced this reality many times that same system is called differently in different communities. And it's sometimes very hard to understand that those two names actually means same system. So naming conventions should be followed. And of course, usage of custom technologies. You can imagine if data file is created using COBOL script. So all logic is inside this COBOL script. It's not an easy task to extract data transformation logic from such script. So this is what I call custom technologies. And the same is related of unavailability of metadata. There are technologies which produce metadata in a standard way. It's built in the system, like database. If you take Oracle, field descriptions, field types, those things are built into the system. If we're talking about just file, which we send, file itself don't have any metadata around it. Knowledge about data inside the file is sometimes only in people's heads. So we're introducing standards how to describe data in such case. And of course, Markus showed already that technologies rapidly evolve and it's to build scanners for every new technology, this is a challenge. Or we can have very complex data transformations when we transform from columns to rows, from rows to columns back, and it's quite hard to follow logic of data transformations. And cultural thing, what Markus mentioned already, with insufficient awareness that metadata is important, then we develop transformations. We should think about how we later will understand what transformations were done. So people should think about metadata already during development. And I said Markus' presentation was inspiring because our aim is to introduce as much as possible automation for developers. But during development, they produce metadata and they send automatically this metadata to central metadata repository. So here is our future vision. But instead of having one central team which collects metadata from all our sources, we're going to establish solution with self-service possibilities and enable different teams to push metadata about their developments. So this solution should support different channels, of course, APIs, Kafka streams, as well manual uploads, because we still will not avoid situations where metadata will be collected manually. But we see that this is the way what we should go to allow decentralization of metadata collection. So this is currently our challenge, where we are going to build the solution. It's not in place yet. So this is our story about metadata management and challenges what we face. And from my experience, it's really interesting topic and very often forgotten by developer teams. So this is my reminder to you that metadata is important. So now we have even 9 minutes for questions for both of us.
I've got a question regarding metadata. Did you get the need of collecting and structuring it that detailed because you switched from the monolith to the microservices? Or was it the need you had before the same? Or that was the context of this? I would be interested in if...
Okay, thanks for question. Of course, this need was even before appearance of microservices. The need of metadata is global. And especially now, the need is bigger and bigger because of our regulators. Because regulators are requesting metadata as a mandatory artifact, in addition to our official reports to our regulators. So this is one part of need. But of course, internal need is as well important because people need to understand and people need to get those answers to questions that I listed.
I would say absolutely. Like we have so many different systems and different platforms, different technologies, COTS products, everything large enterprises do. So having a view of all of it is needed, especially when we're talking about machine learning and everything. Actually understanding what data we are trying to train something and actually do something with is important. And if you don't have that view of all our systems, all applications, it's not going fast.
Just to add one more, that this approach of decentralization in microservices, so we're taking same approach in metadata collection, decentralization, because it's not realistic to govern everything centrally.
As I said, don't fight Conway's law, you will lose. The central teams has a place if you're kind of subject matter experts. But at some point in time, you will not be able to scale. So you need to shift to a more of a self-service, decentralized, and especially in thinking about how do you actually get the cognitive load away from the developer thinking about it to make it easy. Now you say developer don't think about it, so maybe you don't reduce cognitive load, but you're not adding in the future if there's easy self-service.
Exactly, so that's our direction, to make it easy for developers and make part of standard process.
Any other questions, folks? Yes.
He's running.
This is the most exercise I ever get.
So I really like the idea of gamification. I have never heard of that. So my question is, do you have a single team that does that? And I would like more details of gamification, for example. What was the idea of doing that? What are the results if teams are engaged to gamification? Whether we can find more details on your blog. I saw that you have an engineering blog.
Yeah, well, we haven't written anything about this, to be honest. And like, the thing is, like, when you start having a platform, you start having pipeline, you have standard way of reaching production, then you start having standard way of data. When you have standard way of data, you can actually do this type of thing. So this was one engineer's evening project. He thought it would be fun. And that's kind of where it's been scaled. And has it been successful? Yes, absolutely. Gladly to have a conversation with you later.
Questions? I saw another hand. There we go.
I have a question a little bit from the business side, right? Because the customers are like essential for the business. So my question would be, what value does the metadata bring for the customer? Like, how do you use it to enhance customer's journey or something like that?
Interesting question. Of course, metadata is the aim of metadata is to be used internally in the organization. So this is first. But if I think about customer, which gets services from a bank, so having good metadata allows to have better control of our processes, better data quality. So this is indirect impact, but I would say it allows to produce better services for our customers.
All right.
I think we had one over there.
We have one more, thank you.
Hello, thank you very much for a really great talk from both of you. It was very informative. One of the questions I have, it seems you are really well placed in moving towards data mesh architecture. For example, you have Andromeda, which is microservices, is decentralized, and the teams have their own ways of working. And you are mentioning also decentralized metadata collection. Do you also think to have a data contracts between teams as opposed to?
Very good question. And actually, this was a topic of recent discussions. And yes, this seems to the way that we should go further to start signing those contracts with teams regarding metadata supply. Yes.